Hello everyone, welcome to our quick translations lesson. So our previous transformations intro did an overview of our three big transformations, and this is the first one, which is known as translations. Our learning objective for this video, you can see it on the right, is that we can translate objects on a coordinate plane, and that we want to be able to describe how things are translated for the objects on a coordinate plane. First thing we've got to talk about is what is this word I'm throwing out, this translation. So you may have heard several different things you may remember from the previous video. Translation on the coordinate plane means to move. Specifically, it means to move up, move down, to move right, to move left. Those are our three ways. We also call this kind of like a shift or a slide or a glide. Those are other words that we've looked at. So we're going to look at two examples in this video. We're going to first translate some objects and we're going to describe that translation for both of them. So let's get ready for our first example right over here. I have it ready to go. This is our first example. We're going to put a point on this graph. I'm going to put that point right over here at 3, 2, because it's over 3 in the x direction, up 2. So here's our starting point. This is what we would call our pre-image. It's not the most interesting image because I just plotted it on there. I didn't do anything fun with it, so it's a pre-image. And then what we're going to do is I'm going to have us translate this, and we're going to translate it. We're actually going to translate this to the right, and we're going to translate it down. So keep in mind that we're going to have our x directions, our left and right, so we can go both to the right and to the left with the x, either positive x, just like a number line. You can see our numbers get more and more positive as we go to the right, or we can go to the negative x direction. You'll see that these numbers get more and more negative as we move to the left. So we're actually going to translate this 7 spaces to the left. So I'm going to move 7 to the left. When I move 7 to the left, remember that means I'm going negative direction. So I'm going to write this down as x, oh, actually I don't want this one to be black, x minus 7, because that's our direction. So that means that I'm going to the left. And now I'm going to look in the y direction, but before we do that, let's make a little point about where we're going. So I'm going to go 1, 2, 3, 4, 5, 6, 7. There we go, 7 to the left, but I'm not done because I told you that we're going to bring this guy down. So now we're looking in the y direction. Remember, the y-axis can go, ooh, let's change our colors. Oh no, sorry, I changed my different color. It can go up or down, just like we looked at for the x's. As we go higher up on here, we're going more and more positive, or if we go down, we're getting more and more negative. I'm going to bring this 4 down. So that means that I'm going to go 4 down. So I'm going to take away 4 from my y. So I'm going to go 1, 2, 3, 4, and there is my new dot. I'm going to put it in red right here. So there's my image. Now what I want us to look at real quick is what is the coordinate of those images, or that image, that red dot in the middle. And if I count over, I see that it's at -4 and down 2. So all that means that happened is I took my x coordinate right here. I subtracted 7. 3 minus 7 is -4. Aha, that checks. And I took my y variable, which I'm going to put in purple right over here, which is 2, and I subtracted 4. So 2 minus 4 is -2, and that fits right there. So that's translation. And the way we actually describe it is right over here, highlighted. This would be the description of the translation that we did. You could also say things verbally like 7 to the left, 4 down, or the way they usually present it in mathematical notation would be x minus 7, y minus 4. Let's look at another example of this. This one we are going to do something a little bit more fun with because we deserve it. So this is our second example, and instead of just dealing with a dot, I'm going to have us deal with an actual shape. So here's going to be our shape that we're going to deal with. 1, 2, and 3. We have a triangle, and all I did was I mapped out our vertices. And with this guy, that means we have 3 different corners, basically, of our triangle, which we're going to label A, B, and C. We label them with these letters just so we can keep track of what we're talking about. Otherwise, if I say the top corner, and then who knows if it gets flipped around or anything like that. So right now, the coordinates of our 3 vertices or corners, A looks like it's sitting right at 0, 3. B is at positive 2, 5. And C is at positive 1, negative 1. And what I'm going to have us do is I'm going to have us translate this. And the way we're going to translate it is I want to make it 4, oopsies, not 4, 2 to the right this time. And let's move it down again. So we're going to move 3 down. Okay, so real quick, let's describe this movement as we would before. So starting with the x-axis, remember x-axis deals with either to the right or to the left, positive in this direction, negative in that direction. So going to the right, that seems to agree with that positive right here. So I'm going to write this out as, I know I'm going to take my x-coordinate and I'm going to add 2 to it. And then same dealio with my y-axis. I'm looking at it either goes up or down. Down goes to the negatives. Ups go to the positives. So that means that I want to deal with this going down, which means negative. Ooh, that's not what I wanted. Yes, yes, yes. You can see I'm still learning how to deal with this. Oh. Okay. No, don't think this worked. Yes, it did. Okay, great. So that means I'm going to take my y variables. In order to go 3 down, I'm going to subtract 3 from all of them. So there's my transformation as a mathematical description. Now let's find out where our new triangle is going to look at. So for my new triangle, actually I'm going to use red again. So here we go with my image is in black. This is my vertices of my pre-image. The thing that's not as interesting, I just plop it down. Now let's talk about where the image exists. So of course we're still going to end up with a triangle. Nothing should have really changed with this shape. They are congruent, but now instead they will be at different points. So I'm going to find an A prime, a B prime, and a C prime. And the way I'm going to do that is I'm just going to look at where the old ones were. So A was at 0. I'm going to add 2. Was at 3, subtract 3 is 0. I'm going to go ahead and plot that just to make sure. Do I go to the right 2 and down 3, and I'm at 2, 0. Excellent. B prime, 2 plus 2 is 4. 5 minus 3 is 2. And let's track that out. 2 to the right, 3 down. That looks like the point 4, 2. Last one right over here. C started at 1, negative 1. 1 plus 2 is 3. And negative 1 minus 3 is negative 4. Let's check it out. 2 to the right. 1, 2, 3 down. And here is my image once I connect my dots. A prime, B prime, and C prime. So that's how we can translate and describe translations on a coordinate plane.